Hello friends. So already we have discussed about the organic light emitting diode and its details. So now I'll start about the organic photodetector. So how the organic photodetector was developed, that I will discuss today, and some parameters of the organic photodetector. Okay, organic, the short form of the organic photodetector, that is the OPD. Okay, normally, so why we will use the organic photodetector? That is the question, right? Normally, we have seen that lots of inorganic photodetector, these are already commercialized, and we can see in different in our daily life in different application we can see inorganic photodetector, inorganic light emitting diode, right? So mainly organic photo in case of the inorganic photodetector, right? So main is the flexibility issue. Okay, flexibility issue. Due to the flexibility issue, you cannot use for the flexible electronics. Okay, flexible electronics. The inorganic photo we cannot use for flexible electronics, right? Another thing is that so due to the flexibility issue, apart from this complex fabrication process, complex complex processing and high cost. Okay, so due to this you cannot use for the flexible electronics, the inorganic photodetector, right? Inorganic photodetector, IPD. And inorganic photodetector, all the whatever materials we use for inorganic photodetector all have broadband absorption. Broadband absorptions. Due to the broadband absorption, we cannot use for, not suitable for narrowband detection. Okay, without using any filter. Okay, without using any filter. Okay, these two are the main limitations for inorganic photodetector. But we have seen, so lots of research papers are published based on the inorganic photodetector. Who in those papers we have seen that inorganic photodetector can show high stability and high external detection capability, high efficiency, right, and long lifetime period, due to the small exciton binding energy and high mobility. But this can use for other electronics purposes. If we come to the flexible electronics, so for flexible electronics or narrowband detection application, we cannot use inorganic photodetector due to these limitations, right? So to overcome these limitations, inorganic photodetector came into the market, right? Organic photodetector came into the market to limit those limitations. Organic photodetector, OPD, right? First OPD that was developed by polymer compound in the year of 1980. The efficiency was 0.1%. After that, in 1981, small molecule based OPD design, the absorption region we found 400 to 700 nanometer in case of this OPD. Okay, this is the single layer OPD. Only one polymer layer was used, and here only one small molecule layer was used. Right. In 1986, double layer OPD was designed. The EQ found 1%, right? Apart from this, since 1995, okay, since 1995, lots of organic photodetector were designed by employing polymer and the small molecule compound. Okay, in terms of the, if you want to design the organic photodetector in different application, like in terms of different wavelength region, visible for organic photodetector, UV organic photodetector, infrared organic photodetector, broadband organic photodetector, and narrowband organic photodetector. So for case of different these kind of the applications, different kind, lots of huge production was there in terms of the organic photodetector by using the small molecule and the polymer. Okay. So main organic photodetector, right? So organic photodetector, it consists of organic semiconductor, right? So suppose this two metallic layer is there, in between two metallic layer on organic semiconductor, and cathode and anode. So it should apply reverse bias. Should apply reverse bias between anode and cathode. Okay. So this should be the transparent. So all the principle, all the working principle, all the performance, that normally depends on the organic semiconductor, and the energy level align between anode and organic semiconductor, or cathode and organic semiconductor, right? So this organic photodetector. So how it will work? The light will transfer into the device through this anode. Okay, here the electron hole pair will be then photoelectric effect will be this effect will be produced, right? So the light will be transferred through this anode. Inside the organic semiconductor layer, the electron hole pair will be dissociated into free carriers by applying the strong electric field, that may be internal or external electric field, and then the free carrier will be collected by the cathode and anode by external circuit, for which can be followed by the external circuit, right? This is the main mechanism of the organic photodetector. So based on the application, we can divide the organic photodetector into different types. Okay, where we can use mainly the organic photodetector, mainly biological detection application. Biological detection application, full color image application, infrared application. The research is going on for infrared application, optical communication application, health monitoring. So already lots of research papers were published in case of the health monitoring, full color image application. The infrared and optical, these two researchers are still going on. Okay, by employing the organic light emitting diode. So mainly organic light emitting. So there are the huge production of the organic light emitting, or sorry, organic photodetectors. Okay, in terms of inexpensive and large area application. If you need any large area application, and that should be very low cost, so for this kind of the application we have to use the organic photodetector. The inorganic photodetector is not suitable for large area and inexpensive application. So already lots of organic photodetector were designed in case of the inexpensive and large area application. Apart from that, it has the high flexibility and simple fabrication process at low temperature. So due to this, it mainly used for the flexible electronics. And the organic semiconductor that consists of organic photodetector consists of organic semiconductor, right? So organic semiconductor, this can deposit over the comfortable and large substrate. Okay, for that it can be mainly used for printed and the flexible electronic, which cannot be which is difficult by using the inorganic photodetector. If you want to design the flexible and the wearable electronics by using the inorganic photodetector, due to the rigid substrate, okay, due to the rigid substrate, we cannot use the inorganic photodetector. So the organic photodetector is the best suitable material for designing the flexible and wireable electronics, right? And the organic photodetector has tunable detection band. We can tune the spectrum range of the organic photodetector from narrow band to the wide band region, or from one monochromatic region to the other monochromatic region. So for that we can easily use for the printed electronics and full color image application. Printed electronics, due to the this application, due to the this features, tunable detection band, so it can tune different range. So the same photo, same OPD can be detect narrow band, suppose it is 400 to 1000 nanometer, right, wavelength. So it can detect this range, or also it can detect this range, or it can be used for only this purpose, or it can be used for entire purpose. Okay, same organic photodetector by applying forward bias or reverse bias, by transferring light through the anode or through the cathode material. Okay, so this thing we will discuss later, right? So now come to the these are the main advantages of the organic photodetector and features of the organic semiconductor and organic photodetector. Now one by one I will discuss about the working principle of the organic photodetector. So if you design any kind of the photodetector, this is one kind of the device, right? So normally if you want to characterize the performance of this device should be modeled, right? This device should be modeled, okay, in terms of the circuit, equivalent circuit. So if you draw the equivalent circuit of the organic photodetector, here I told that this is the cathode. Inside the cathode and anode, organic semiconductor layer, and this is the anode, right? This is the metallic layer, this is also metallic layer, this is the organic semiconductor. So if you want to draw the equivalent circuit, why the equivalent circuit is important? If you want to know the internal performance of that organic photodetector, how it is affecting by applying the light or by applying the bias, how it will control the other parameters, how the reporter, if you want to achieve the performance, achieve the high performance, how the internal parameter controls the other performance, electrical performance and optical performance, right? So by knowing the equivalent circuit, we can determine the internal parameters, the circuit parameters. Okay, so if we draw the circuit diagram normally, so organic photodetector, this is a diode, right? So one diode should be there, right? So the purpose main is that it will produce the photocurrent, right? So if we increase the intensity of the light, okay, the photocurrent will also increase. That is linearly proportional. Okay, this is the light intensity versus IP. So if you plot this graph, it is linearly proportional. So as it is a photodiode, the one diode instead the equivalent circuit, one diode should be there, right? Okay, this is the diode current. Now here I am adding one capacitor. Why the capacitor? So means here I told that this is the two metallic layer. Normally capacitor will form so between two metallic layer if insulator is there. If an insulator is there, so this will produce the capacitive effect, right? So in case of the organic semiconductor also, some capacitive, some insulating effect is there inside the device, right? So due to this, we will get a one capacitive effect, right? One capacitive effect. After that, here I am drawing shunt resistance. This is for IN, noise current, okay? So in case of any device, we will get some noise current. Noise current means this is the unwanted current. So suppose under the reverse bias condition and without application of any light intensity, we should get less current inside the device. But if we are getting with few current, that is the noise current, right? So due to this, if current is there, there will be a shunt resistance. This is the noise current and shunt resistance. Now, one series resistance is there. So series resistance means, so here this is the metallic contact, right? So in between organic semiconductor metallic contact, there will be one resistive effect, okay? There is, and suppose if you connect any kind of the wire, okay, for measuring the current versus voltage curve, we have to connect the copper wire or anything, okay. So for that the resistive effect is there, RS, right. After that there will be one load. So if we if want to measure the diode voltage, okay, if you want to measure the diode voltage and to control the current of the diode, the load resistance should be there, right? So this is the load resistance. So this, as is there, the photometer is a diode, so diode should be there. Due to this kind of the structure, capacitive effect is also there. And in case of any diode, there will be some noise current. For that noise resistance, and due to this connection, extra connection, the series resistance is there. And to measure the output, and the external circuit, we have to connect the load resistance and to control the current also. This is the equivalent circuit. So how we will get the value of this parameter? So if you measure the current versus voltage curve, so by fitting different kind of the equation, we can get this kind of the we can get the values for this kind of the parameters, okay. So once we know the parameters, so that we can understand the performance of the organic photodetector, right. And apart from the current versus voltage curve, we can also measure different kind of the parameters, so for calculating this kind of the values, right. So this strongly affects the performance of the photodetector, right. So how we can how if we want to achieve the performance, so we have to reduce this resistance and this noise current and capacitive effect, because capacitive effect also influence the response speed, right. So this is about the circuit model of the organic photodetector. So next class I will discuss about the brief idea about the how the organic photodetector is working, and the how many types of the organic photodetector is there, and to design the organic photodetector, what are the main features and criteria should require. This we will discuss on the next class.